Welcome everyone. We are Team Agrofortifiers from TESIC BSc Bengaluru. We are here to demonstrate our product, the Smart Farming Assist, which is made for the TI-IICDC 2K19 competition. Our main focus is on the irrigation in the Indian agriculture. Here we form a network using the microcontrollers. We have a master microcontroller as the host and the slave microcontrollers which form a network with it. For our master microcontroller, we are using the C2000 microcontroller of the Texas Instruments, and our slave microcontroller is going to be the MSP430's launchpad. Our master microcontroller is interfaced with these sensors here. This is a current sensor which is used to measure the current being delivered to the irrigation pump. This is the GSM and GPRS module which is being used for communication of the master microcontroller with the other peripherals. This is the main pump controller. We are trying to control that with a relay from the microcontroller to the irrigation pump. This is a temperature sensor which senses the temperature of the external atmosphere in the farmland, and as you know, the sun and all. Here is the humidity sensor which senses the atmospheric humidity, and we can even upgrade that to provide weather reports for the farmer. Here is the pH sensor. pH indicates the presence of hydrogen. It indicates the acidity in the soil. Here is our water flow sensor. We are using a water flow sensor for this application, and we have interfaced that with the microcontroller. And all this is powered using solar panels with this DC power supply. We are interfacing all our sensors with the TX microcontroller, which provides an integrated solution for all the farming needs. There are many products available in the market which can do only for a specific application, but our product is an integrated solution. We are even capable of building our product to be customized for each and every farmer depending on the size of their farmland and its terrain.
The slave microcontroller used here is the MSP430 launchpad. The inter-network of these slave microcontrollers collectively share vital information about the field with the master controller. The slave microcontrollers are placed in optimal locations in the fields so that accurate data about the fields can be processed by the master controller. The slave microcontroller here consists of three components connected to it which share information with the slave microcontroller. The first component here which is used is the moisture sensor, which is placed in locations close to the plant so that the moisture of the soil can be detected by the moisture sensor, and accordingly the microcontroller can decide whether the solenoid valve has to be opened for flow of water or not. The RF module which is connected to the slave microcontroller is used to communicate with the master controller so that information about the field can be transferred to the master controller. Also, there is a possibility that the field of a farmer is of a larger size. In case of extremely large fields, a small repeater would be used, which can be avoided by interconnecting subsystems to the main system, which avoids the use of repeaters and also increases the accuracy of the output we get